So next, we want to look at troubleshooting the transformer with your digital multimeter. So we want to look at the components in a transformer, the composition of a transformer. So as we all know, the active component of the transformer is the windings, okay? And in all transformers, we have the primary section and the secondary sections of the transformers. So these transformers, when you are making, well, when they are making the windings, okay, on the transformer, there is what we call a former, okay? So each of the winding is made on the former, and that former is made of insulated material, okay? That material is an insulator. So on that, after the windings have been made on the former, the yoke, okay, or the iron core is placed inside the former, okay. Now that brings us to the second component, which are the active, inactive component of the transformer. So in some transformer, the secondary and the primary, they are electrically isolated. They don't have any connection with each other whatsoever. While in some others, like the auto transformer and in some other connections, the primary and the secondary may have some form of connection. So you have to be aware of this. So, like we said, this is the yoke of or this is representing the yoke of the transformer. This is the outer casing anyway, but it's actually covering the yoke. Okay, so these are the form. This is the former, one for the primary and the other for the secondary. Okay, now if you look at it, you see that we have the primary terminals, or it could be the secondary terminal, one set of windings here and then the other set of windings. Okay, so you see from the diagram of the transformer, you see the center tapping from the middle of the winding. So the major component in the transformer are one, the winding, which is the active component, the winding, which is the active component, and then the yoke, okay, which is this casing, okay. Those are the major components, okay. Like we said earlier, the primary and the secondary, they don't have any electrical connection, okay, but they are coupled by the magnetic field that will be created in the primary winding once it is energized. So those are the active part. Then you can carry two forms of tests. One, when the transformer is active, and two, when the transformer is dead. That is when you have voltage at the primary, okay, the input terminal of the transformer, and when there is no voltage at the input terminal of the transformer. So when there is input voltage, assuming you have 220 volts here, okay, you can use your digital multimeter to test these terminals. Between the T1 and T3, you expect to have 24 volts. Between T1 and T2, you expect to have 12 volts, okay? So transformers, irrespective of the size, they are, whether you are talking of a transformer of 1 MVA, 20 MVA, 100 MVA, or transformer of 10 watts, 3 kilowatts, the working principles, they are the same thing, okay? So now you can test for continuity of this winding, and then that is when the circuit is dead. You can test for continuity of this winding, and you can test if we have short to the frame or the yoke of the transformer that is short to earth, okay, or to ground in the transformer. Then we can also test turn-to-turn short. That is when we have a short between the primary and the secondary, especially on transformers that we have the secondary and the primary wound on the same former, though they will be separated by an insulator, okay? But if that insulation fails, the possibility of us having a short between the primary and the secondary is there. So those are the tests that you can carry out on the transformer. So you can see this is the yoke of the transformer. Then you see we have the two set of winding on separate leg of the yoke. So in this kind of arrangement, the possibility of us having winding to winding short is that is a short between the primary and the secondary is very, very low. Okay. So what you do in this case is that you can test for continuity when the circuit is dead. You can test between the winding and ground, okay, on the primary side, and then on the secondary side you can test between winding and ground and test for continuity. You can also carry out the resistance test. Smaller windings like this, they have high resistance, so you can use the digital multimeter at the lowest range to test the resistance of these winding. But bigger wire, they have very low resistance, so you may need, or you will need the milliohm meter to get the actual resistance of these windings. Okay, so on the secondary part too, you can test earth to ground. You can test winding to ground too. Okay, then like we said earlier, you can do live tests, which means you power the transformer by supplying inputs to the transformer and then testing the voltage output from the secondary. So you expect to have what the transformer is, the expected output from that particular transformer is what you should have. If you are not having it, that means there's a problem with the transformer. So here is an example of the transformer. This is the yoke, okay? So this is the winding, yoke covered. So the winding, the terminals are connected here. So we have both the primary and the secondary winding terminals brought out to this terminal block. Okay, so now whichever that is the input, the primary windings, they are usually marked. Okay, so you can, assuming this we are looking at this transformer now, it means that two of them will be this particular transformer that is represented here. Okay, assuming it's this, though we know it's this, but assuming it's this, then two of them will be the primary, that is the input. Then these three will be these three output terminals. Okay, so now you can test for continuity while the circuit is dead. Test for continuity and then test if the winding is shorted to ground. That is the test that you can carry out when there is no power to your transformer. Then you can also test the resistance between, that is the resistance of the windings, each of these windings. If it is high enough, you can use your digital multimeter. But if not, like we said earlier, you would need a milliohm meter. Okay, then you can power it and then test the output. So those are the tests that you can carry out. You can also test between the winding and ground. Okay, this is the ground. So this is the format that we earlier explained. The winding is inside, is made on the former. So that is how you can use the digital multimeter to test the transformer. Okay, so importantly, you should know what you are looking at. That one is very, very important.